Hola, chaps. Let's learn. Hola, chaps. Mr. Turek here. Welcome back from spring break. I have published a syllabus for you students to follow that says basically, if you have Autodesk, do this. If you have SDK, do that. If you have Robot C, do this. If you have, so you're on your own for a lot of that. One part of what I wanted to go over is to have you do some POE calculations that you might not have done last year. But before that, I had assigned that you do a reaction time program on your TI graphing calculator. And during the last Zoom meeting that we had done, I kind of debriefed the students who showed up for the Zoom meeting, but that's only a small fraction of all of you. So I'm going to take this time right now to share with you the program that I created and talk about it a bit. So first, I'm going to just show you the listing of the program. And although I've written this on a TI-84 Plus Color Edition, it is written in a program that is executable on a TI-82. And that brings up an issue that some of you didn't take advantage of what you're capable of doing on your own calculator. You tried to use a more sophisticated program than your calculator could handle, and so you weren't able to actually get the program to work. So here's a listing of the program. I'm going to scroll through it for a moment and then show you a flow chart that kind of talks you through it and then come back to this to help. So here's the first page of the listing, and I'm using 4 statements. You might notice that the word repeat isn't used anywhere here because that's a command not available to the lower models of the TIs. So I'm using commands like for and while. So I'll go over that in a little bit, but scrolling a little bit so you can see it. Here's the program. C is a time counter, T is total time, and there's the entire program listing. All right, so to start talking you through what that is showing, I've written a flowchart that goes with it. Of course, really, when you design a program, you should start with the flowchart, not end with it. But I'm guessing you could make sense out of this, maybe with a little help from me. So the program starts with a menu, and in the menu, I ask, do you want to run the reaction time program or do you just want to quit? So really, it's a 2-choice menu. If you choose quit, then the program ends and we're done with it. If you say, oh, I want to start running the program, then it goes to the label where this clears some variables. I don't know if this is readable to you. Good thing I'm here to talk you through my own handwriting, huh? Okay, so clear whatever timing variables you have. Then, instead of using repeat, I used a for counter. There are other ways you could do this as well. There's something called increment and skip on 0. There's one called decrement and skip on 0. I'm choosing to use a for statement, which says use a variable called I, and here's its initial value, 1. Here's its final value, 10. And by default, it increases by 1 every time it goes through this loop. So this loop will execute 10 times with I starting with the value of 1, and on the 10th pass through this, I will have a value of 10, and then it'll try one more time. I will become 11, and it'll fail and not execute the loop. So as long as I is less than 10, which is what I attempted to write here, I is less than 10, then generate some random amount of time to wait. I told you make it sometime between 1 and 8 seconds. Clear the screen. And by the way, wait that amount of time. Clear the screen. And I chose to have a message appear at some random location on the screen. So knowing that there's 16 columns on a TI-82 and 8 rows on a TI-82, I had to randomly pick some coordinates that would allow a 3-letter message to be printed. So if there's only 16 columns on your screen and you have a 3-letter word that you want to post, you don't want to start posting it in column 16 or 15. You could start in column 14, 15, 16. All right. So I had to output the word now someplace on the screen randomly. Then I reset a timer. And this is a little messy here, but basically, if a key has not been pressed yet, then increment the timer, which I calibrated to be 1/100th of a second per cycle, until a key is pressed. And once the key is pressed, great, then tally up the total amount of time that the person has spent with this reaction time, add it to the total for all 10 trials. Go through the loop 10 times. So I guess I need to zoom out a little bit so you get the big picture again. Go through this loop 10 times. Once you've completed the loop 10 times, now you clear the screen one last time, calculate the average reaction time, which means take the total out of 10 trials, divide it by 10, and display the results, and then pause until the user presses the enter key on the calculator. Otherwise, this display will quickly clear and you're back to the main menu before you had time to study the results. So this is the flow chart for the program. Now I'm going to bring the program listing back up so that this time when you look at it, maybe it makes a little bit more sense to you as to what you're actually seeing. So actually, I'm going to go like this, make it more convenient for me, and that's readable for you. All right, so this label means start at the main menu, and you could have picked a number like all of you did, or you could pick a letter that says M for main menu. And here's the menu. I chose label S for the start routine. So you don't have to just pick numbers. You could pick letters that are meaningful as well. I cleared the timer here. Here's the beginning of that loop that says, carry out this experiment 10 times. On this line, I'm generating a random number, and turns out I scaled it so that it's between 100 and 800. But when you increment a counter on a TI-82 or higher, you can't tell it to go from 1 to 2.3. You have to tell it an integer value. So I rounded the wait time, using W for wait time, to the nearest whole number. Then I counted to myself in this little for loop that says, well, for j equals 1 to that random time, which is somewhere between 100 and 800, count as fast as you can. Once you're done with that loop, clear the screen. Now I chose to generate a random screen location to print the message. So there were 8 rows available. So from row 1 to row 8, there are 16 columns on the TI-82, but I have a 3-column message, so I didn't want to go and start printing it in column 15. Otherwise, it would word wrap. Again, rounded those off to the nearest whole number. And by the way, on the TI-84 Plus, you actually have more than just these values. But I put these values in for those of you who are using a TI-82 or 83, that you could just copy this code directly and place it and get it to work. If you have a TI-84 Plus Color Edition, you have more than just this number of columns, more than just number of rows, and you would just change the upper limits here. Here's the part where you now, as soon as you display the message that says now, you zero out your timer, your counter, and while no key is being pressed, you increment the counter and loop, increment the counter loop, increment the counter loop until any key is pressed. Now, if you wanted to upgrade this, instead of displaying the message now, you could display a message that says, press the, and pick some number, press the 5 key now. and the person has to actually read it, interpret which key has to be pressed, and then press the correct key. That would be a more interesting reaction time program that would include how much time it takes you to think and move your finger to the correct key to press. It'd be great if you did that, but here's a simpler version that you guys should just get this to work. All right. Once you've pressed a key, add the total time to the accumulated time for this one run, clear the screen, repeat this loop that says 4, 1 through 10. Once you're done with that loop, clear the screen, display, here's my average reaction time. By the way, a lot of you chose to do the calculation, store it in a variable called f, and then display the message in f. But strictly speaking, you don't have to display a variable. You can display the result of a calculation in that line. So here, I took the 10 total accumulated reaction times and divided it by 10 on the line in which I actually display it. It's one less line of code. It's also one less variable in memory in your calculator. Here I'm pausing, and then once you're done pausing, you go back to the main menu. I actually have a label for quitting, Q for quit, and it's the stop command. So that should explain to you how you were expected to write a reaction time program. And ideally, you would have figured it out on your own, debugged it, and then now consider doing some upgrades for it. So that's my debrief on this episode. The next that I share with you in aerospace engineering, next video will be trying to guide you through doing free body diagrams. All right, ciao. Ah, I forgot. I should show you a demonstration of the program running. So here we go. Reaction time by an old white guy. And the menu says, I'm going to choose to start. And now, now, now. At least I'm still alive. So on this example, my average reaction time comes in at 0.429 seconds. Really should only be displayed to the nearest hundredth of a second. So 0.43 seconds in my case. No doubt you kids will have a much better reaction time. All right, ciao.